And then I've got most of the problems from the mastery test ready to go that we can work through together as a group in class. And then I will be having you guys do the mastery test afterwards as your homework for today. That's our goal.
Mike?
Go ahead. Maybe I heard someone's mic, I thought. At any rate, my goal for today is to finish this lesson from yesterday with you. And then I've got most of the problems, I think 6 or 7 of them, from the mastery test ready to do as a group. I'm going to have you do it on your own, though, afterwards as your homework assignment. The one called Lines, Angles, and Mathematical Proofs. But we're going to work through as many as we can today before you even do it on your own. So that way you can have seen it and done it with me as a group, and then you'll do that mastery test as your assignment for this.
What are you doing? Dawson, can you check on my dog?
Hey, Xavier, just for now, would you mind turning off your mic? Sorry, but thank you. If you have a question, as always, and this goes for everybody, I want you to turn that mic back on and ask your question. Or you can type it in the chat, as always, okay? But just for the background noise. So, a quick warm-up question. I'm going to write it here in the middle. Just to quiz you on what we did yesterday. So, warm-up question for right now, for today, is for all of our proofs,
Good morning, teacher.
Good morning, Victor. For all of our math proofs, what is always the first statement and reason that we're going to use for every math proof? Can you remember from yesterday? There's always going to be something that we use for the very first line of our math proofs. What is the first statement / reason we use? Go ahead and think about that for a moment and type your answer in the chat. Every proof we do will be a little different because it'll have different information, and then we're supposed to prove something different. But that said, there's always something that is like consistent in the same force that we'll use for every math proof for the very first line, the first statement reason line. That's our warm-up question. See if you can remember that or see it in your notes and type it in the chat.
Hi, Josiah. I wanted to apologize for being a little bit late. I was having some trouble connecting.
No problem, Levi. And I appreciate the apology. I do the sentiment. I appreciate that, but it's okay. And thank you for joining. You're only, according to my clock, 6 minutes late. So I'm just glad you're here. 6 minutes is better than 26 minutes late. You're good. Quick question, Levi. I asked the whole group. In the red box I just drew, if you can remember or see it in your notes from yesterday, what is the first statement and reason that we always use for all math proofs? All of our math proofs will be a little different because it's different information that we have, and then it's different, a different thing we're supposed to prove. But there's something consistent and the same that we'll always do every time.
I'm pretty sure that it's proving how it's true.
Yes, that's true. We'll always want to show how it's true, like all those steps in the middle, right? What was there's a special name we use for the very first step. Let me write that down just for everyone to see it. There's a special name that we have or we use for the very first line that we will write down.
The reason of equality? Or
it's okay. I think that sounds like one of the like reasons that we used in probably a couple of our different proofs yesterday. It's all good. So I just wanted to guys get you all thinking about it again. Brooke, good morning. Glad you're here. So here we go. Let me see what the folks typed in the chat. Tatiana, Jacob, Ananiah. Okay, awesome. So I'm glad I saw from and Levi, you too, for jumping in and answering verbally. So the special name we use for that first line, everybody, is the given. Da-dun, da-dun, the given. That's the information that they'll give you to start with. There'll usually be a picture and there'll be some kind of description as well. And that's going to be our statement. And then our reason for it is we just say given. It's what was given, it's what we are assuming. So just a quick note what given means. What it means is we assume it. We assume it's true. So there'll always be some information they give you. And then the reason for it is that it's a given. So high five to you four for jumping in and trying that question. Thank you. So I'm going to pick up where we left off yesterday. So for today's notes, we're going to start right here. We did a proof about the linear pair. And now there's a couple more definitions I want to do with you. We'll do some more practice problems. And my goal for today, just so you all know, because there's a few folks that just joined more recently, the goal for today is to finish this lesson. We'll do some more definitions. We'll do some more examples. And then I have almost all the problems from the first mastery test ready to go on my screen. And I want to just do those with you as a group. If you're following along and you're taking notes, you'll have those available. And I'd like you to try them with me as well. So it's not just me and one other student doing it. Hopefully we're all trying them at home. And if you can type your thoughts or your ideas or your answers into the chat, then we'll all be working on it together that way. And then you'll have some answers ready to go for when you do take your mastery test later. That's my goal for today. So we're probably not going to, honestly, I'll just be honest from the beginning, we're probably not going to have time to finish this whole lesson and then have you independently do the mastery test in class, just because there's a lot of information and I want to do a lot of practice with you before I tell you to go do it on your own. So my goal is to finish teaching any new stuff, do some more examples, and then we'll start some mastery test problems as a group on my screen. And the homework for today will be to do try to do the mastery test on your own and have that done for when we come back from break. Sounds good. Awesome, Xavier. Thank you. All right, folks. So here we go. 2 definitions we're going to have to add to our repertoire for geometry stuff. We'll start with the top word. It's congruent. 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 Practice saying that out loud for me at home. You can just leave your mic off, but practice saying it, please. Congruent. What congruent means, to make it the most simple, it means 2 shapes or figures are a match. It means we have 2 distinct shapes and they are a complete match. We can have congruent line segments. Line segments are a shape and they're a common one we'll use. So congruent line segments, a little example here. Here's a line segment I just made, AB. And if I have another one, CD, and if those are the same length, like 5 inches and 5 inches, segment AB and segment CD, they're not the same exact segment, right? They're 2 different shapes, 2 different figures in the universe that exist, but they're a complete match. 5 inches, 5 inches. They have a matching length. So we could say that segment AB, and here's a symbol, is congruent to segment CD. So this symbol means congruent. Let me write that down. Look at the symbol. It's an equal sign with a little nice squiggly on top. And what that means for us in math going forward is it doesn't mean equal. It means that they have equal measures. It means that the two shapes are a complete match. And if I did some transformations on A, B, or C, D, I can get it to line up and land on top. We might have to do a rotation and a translation, but we could match one figure to the other. We can also have congruent angles. So I'm going to put this below, congruent angles. An example with a picture. Let's say we had angle. I already used A, B, C, D, so let's do angle E, F, G. So here's one angle. And if I had next to it or somewhere in the universe a second angle with the same exact size, EFG, HIJ, we'll say angle HIJ. And if these are a complete match, in my example, let's say that this is 45 degrees for EFG and HIJ is also 45 degrees. I want to stress again that they're not the same shape, right? They're two different entities. However, they have a complete matching degree. So therefore, we could say angle EFG is congruent to angle HIJ. And we could have other congruent shapes as well. Maybe we have two squares that are a complete match, or two rectangles that are a complete match, two triangles that are a complete match. Today, and for this mastery test, I think we're going to just focus on these two. But just keep it in mind that you could have any shape really in geometry that are, as long as they're a complete match for their measure or their degree measure, that means the whole figures are congruent. And our symbol for congruent, I'm going to put it again over on the left side underneath the word, is this. Equals with a squiggly means congruent. Let's do vertical angles. Quick question for the whole group. And it's okay if the answer is no. Totally okay. But I'm just wondering if maybe you've heard or used this word before, vertical angles. Has anyone used this before in math class or heard it before about math? If you have, go ahead and tell me in the chat. I'll just wait a few moments. And you won't have to explain it, but I'm just curious if anyone has heard it before or used it before.
I've heard it before. I actually use it quite frequently because when I change my insulin pump, my site has to be at a vertical angle in order for it to go in.
Very interesting. I did not think about that. Okay. Interesting. Thanks, Levi, for sharing. So I don't want to put you or anyone on the spot, but I'm just very curious about that. So you know what? Here's what I'm going to do. And I see in the chat, a couple people are saying, yeah, we've heard of it and used it. And some are saying no. So let's talk about vertical angles. And later, Levi, if you don't mind, you can tell me if my math description matches up kind of with how you use it too. Okay. I'm just curious because I'm a curious person. So vertical angles in math, what this means is that two lines are crossing and the vertical angles are the opposite angles. They're across from each other. So I'm going to write that down and we'll draw a picture. Two lines are crossing. Vertical angles are across or opposite of each other. Across from or opposite each other. Let's draw a picture. So two crossing lines. Here's one. Here's another. Now they don't have to be at a, you know what? Stop. I'm going to really quick erase my last line. I don't want it to look like a right angle. I just want it to look like any two random crossing lines. So here's my first line. I'm going to call that MN, line MN, because there's 2 points on it, M and N. And then we'll have a second line cutting through like this. There we go. And that'll be line OP. So we've got 4 different angles that have just been created when we have 2 crossing lines. Let me point them out with a different color. So here's one angle, but the one in between O and N. And I didn't label my crossing point. Let's call that point X. So the green angle I just drew in there, I'm going to draw it again. This is the angle space. That would be angle OXN, starting from one side, going to the vertex, and then up to the other side, OXN. The angle across from it is down here. I'm going to draw that in. Angle MXP. So let's write this in green now. Angle OXN and angle MXP, M as in Mary, XP, are vertical angles in this picture. They're across from each other, or they're opposite sides of that X, the intersection point. So OXN and angle MXP are vertical angles here. And check this out. Not only are the 2 green angles vertical, but there's actually 2 more that are vertical that I didn't draw in. Do you see the other 2 angles that we haven't drawn yet? In orange, look at the other 2 angles created by the crossing lines. Angle OXM, as in Mary, and then across from it, angle NXP. So every time we have 2 lines crossing like this, there's 4 angles there, and the 2 sets that are opposite each other are both vertical angles. In orange, angle OXM and angle N, as in night, NXP, are also vertical angles. So this is just a definition, and now we're going to prove something. We're going to prove next that vertical angles are always congruent to each other, meaning opposite angles like the orange 2 or the green 2 angles are equal measure. Without even knowing what the measure is, we can prove that they are equal in their measure, and that makes them congruent angles. I'll wait a few moments if people are writing. And if there's any questions, now's a good time to jump in with your questions. Please, comments. Okay, no comments or questions yet. It's okay if there are. I want to hear from you guys, but okay, let's try our proof. If you need more time, let me know on this screen. Okay, let's jump in. We're going to prove that vertical angles are congruent to each other. All right, and I didn't take any notes for this one, so we're going to do it from scratch. So example 4, given 2 crossing lines, prove that vertical angles are congruent. So this is just like our last diagram. We've got 2 crossing lines here, and look how there's like 4 different sectors made. Like I see a top, a right, and a bottom, and a left side, right? So those little sectors I just pointed out, those are basically our angles. Angle AED is the top one. And at the bottom, we could call that angle CEB. And then left and right, we've got angle AEC on the left and angle DEB on the right. And our goal is to show one step at a time that my two yellow or orange angles on top and bottom have to be congruent to each other, or we could show that the two purple angles side to side are congruent to each other. Savannah, you missed a little bit, but I'm glad you're here. So just jump in with us. We're just continuing yesterday's lesson. Okay, I'm going to remove the numbers because we do want to use the right language and refer to our angles with their 3 points, okay? So I just want to practice that. So let's start this. For the warm-up, we talked about how we always start a proof. So we're going to start, well, I guess how we really always start is by making our table. We're going to say statements. Statements are like using the math from the problem, and then reasons next to them on the right. Statements and reasons. And we talked about what's that first line going to be? It's going to be the given. So what's the given this time? Can anyone tell me from the writing what our given is? What are we being given, or what are we assuming for this question? Can you see it from the writing in the question? Anybody?
I think we're assuming that A, E, C, and first A, E, and C is a vertical angle.
Okay, good. Levi, you are doing terrific, and you see the vertical angles. I want to pause you real quick and, in a sense, back you up a little further in that thought process. You're getting ahead of the game, and that's a good thing. I don't want to turn you off from that. You're doing terrific. What you're saying is going to be used, I think, somewhere in the middle of our proof as one of our steps. But even before that, what do we have to get those vertical angles? I'm not trying to pick on you, Levi. I'm asking the whole group. Before we even get to the vertical angles, what do we have that makes the vertical angles? Let me ask that way. 2 crossing lines. And in the writing, they said that right here, given these 2 crossing lines. So we're going to say we have 2 crossing lines. It might be, so I could say that. What are we going to say? We have 2 crossing lines. Why do we have those? Because they've been given to us by the math gods, basically. What's our reason? We say given. Now, we probably should be a little more particular because we're going to need to refer to these parts. So I'm going to keep my statement as we have 2 crossing lines, but let's name those 2 crossing lines. So let's practice this together, folks. One of the lines has the A. Check this out. On the left, see the A point? So what's another point that's unique to that line that's on the line? It has an E and a B. You see that? If we start on that line and look kind of downwards, it's got point E and point B. Which one is unique to that line that the other line does not have? The B. See how point B is not on the other line? So I'm going to name my first line AB. I'm going to look up in my statements now. Line AB is crossing with what? What's the other line that's crossing over AB? Can anyone take a guess at that? What do we call the second line? Oh, in the chat. Thank you. I see someone in the chat. DC or CD. Savannah, correct. In the chat, Savannah said line CD or line DC, and that's good. We can name it either direction, but we have to use some points that are on the line, C and D. So we have line AB is crossing line CD, and it's okay if you named it DC, that's fine too. Okay, cool. And I'm just going to keep that as part of my first statement. So statement 1, we'll label these to make it clear. Statement 1 is we've got 2 crossing lines, and they're named line AB, and that's crossing line CD. Why can we say this? Because it's assumed, it's given. There's our reason on the right. Now, Levi was jumping in and doing terrific. Levi was pointing out that these are vertical angles. Now, you're right. Why are they vertical angles? It's happening because of the two crossing lines. So let's name those vertical angles, okay? Let's talk about one of our purple ones first. How about the left purple angle? Angle AEC. When we name an angle, we have to have all three letters in one of the directions. So like we could call it AEC, or you could call it CEA. It's the same angle. This left purple angle is angle AEC. And that's vertical with the one across from it. In the chat, I want to ask you all now to just practice naming the angle. We want to identify and name the vertical angle to AEC. What is the angle that's across from? Across this way from AEC. What's the one across from it? The vertical angle. Anybody? Go ahead and type it in the chat or say it out loud if you like. I see one in the chat. We're just practicing. Good, Levi. DEB. Wonderful. Perfectly done. So Levi named it DEB. And just so you know, because Savannah pointed this out, you could name it the other direction. We could call it also BED. As long as we use those three in one of those orders, we're good. So angle AEC is vertical to angle DEB. How do we know that? The definition of vertical angles. We just defined it last screen. That's what a vertical angle is. Definition of vertical angles. I'm going to use a little shorthand and use my symbol for angles, okay? Definition of vertical angles. Terrific. What else do we know or can draw from this picture? What's some more evidence? And remember, I'm going to put at the very bottom right now, I'm not going to number it because I don't know what number it'll be. But what are we trying to prove here? We're trying to prove that vertical angles are congruent. So we're at the very bottom of our proof, we're aiming to have angle AEC congruent to angle DEB because we just identified a set of vertical angles, right? So let's go ahead and put that down there. That's what we're trying to prove. Now, I don't know how to get there yet. So we're going to put that at the bottom as a helpful reminder as to like where we're heading. And now we want to overthink and use every step at a time to show that those are equal measure, the two purples, AEC, DEB. There might be more ways to do this, but one way that I'm thinking of now, I'm going to kind of explain my reasoning to you, and then we'll try to lay out all the statements and reasons in our table. Think about this question for a second. You don't have to answer, but think about it. How many degrees is a full circle? Do we remember that? Every full circle all the way around is 360 degrees, right? So in our picture here, high five, Savannah, thank you. In our picture, we have 360 degrees if we were to add up all four angles. If we added up yellow and then the purple and the yellow and the purple going around, those should add up to 360, right? Okay, and I just thought of a way we can maybe tighten that logic up. What about a straight line? Remember, we talked about this yesterday. Straight lines, linear pairs like this, these two linear pairs always add up to 180. Regardless of what the two angles are, they will sum to 180 degrees. Now, in red, notice that we have like two straight lines going on in our picture. why don't we focus on one of them for now? Let's say line AB down this way is a straight line, right? So that means yellow angle on top and the right and the purple on the right, those should add up to 180. And on the bottom side of the red line, that purple and that yellow should add up to 180. So let's try to see if we can say, we'll use the 180. We'll use the fact that these two linear pairs are adding up to 180. So let's say this for statement 3. We haven't introduced the two yellow angles yet, so let's put those in. The top yellow is angle AED. And the bottom yellow is angle CEB, as in boy, CEB. And what are those? They're vertical. That's the definition of vertical angles again. Let's see. If we're going to try to use the fact that the yellow and purple combos add up to 180 each, then we might want to introduce the fact that those are linear pairs. So I'm going to put those in, and I hope I'm not going to run out of room. So looking at the top of the red line I drew in, AB, the top yellow is angle AED, angle AED, plus angle, the purple, DEB, equals 180. Now, why can I say that? Because they are a linear pair. So I need to mention that somehow for my reason, definition of linear pair. And yesterday we proved that linear pairs add up to 180. And if we put the same thing in for step 5, except for the bottom angles, so angle AEC plus angle CEB, that also equals 180. Again, definition of linear pair. Okay, now we can set those two equations equal to each other because they're both equal to 180. So now we could set them equal to each other. Hang on, let me think for a few moments here. But we don't know yet that those are equal measure. So we can't subtract anything. Okay. Sorry guys, 1 second. I wanted to put the two equations equal to each other, the two different sums of angles, but then I thought I could subtract out something that would be the same as each other and then have AEC congruent or equal to DEB at the bottom. But I don't think we can do that because we don't know that we can subtract yet if they're not technically equal to each other yet, because that's assuming what we're trying to prove. So you know what I'm going to do? Rather than sit here in silence and wait because I can't think of it, here's what we're going to do. We're going to come right back, but we're going to look up online and see another proof really quick. Keep it. And see what the wide world of the internet might offer. Prove vertical angles are congruent. Yeah, that's what I started. Proof. So they're not doing a 2-column proof. They're doing it in just like written, just thought process only. Angle 1 and 2 are linear pair. They're supplementary. 2 and 3 are a linear pair, so they're also 180. Subtracting angle. Oh, snap. Okay. Geez, Josiah, how come you can't figure it out? All right, let's go back to ours. Now I see it. Okay, well, in a way, I'm glad this happened because it is going to be trial and error when we're trying to put together a proof. When I was in college doing proofs, that's like all it is in math. After you reach a certain point, it's just proving everything, and it's crazy. It's a lot of fun, but it's crazy. It's a lot of trial and error. So I've got steps in here, some of my evidence that I might not really need to get to the proof at the bottom. I was trying things. It didn't lead anywhere logically, so I'm kind of backing up and rethinking, reevaluating how I'm doing this. So in a way, I'm happy that this happened. Although I am embarrassed that I couldn't figure it out in front of you, but oh well, whatever. Life happens. So we're going to use some of what we've wrote. The top yellow angle and the right purple angle are forming a straight line, the red line. They're forming a linear pair. AED is a linear pair with DEB. So at step 4 here, for our statements, that's where I'm going to pick up at. And you know what I'm going to do? Go ahead. If you have written down line 5, I'm going to cross it out or just erase it this time. We're going to do a new line 5. Oh, I've saved it. Perfect. I want to rethink what I'm doing and do a new line 5. So I'm going to cross mine out. New line 5. So here's the approach. We've established that we've got a linear pair. Now check this out. Visualize another linear pair, not the opposite side of the red line, but using part of it. So here, I'll use blue. So we've got the other line, CD, going this way. And we have a linear pair. I'm going to show it in blue here. Those two angles, okay, are forming that straight line. So let's write those out now on line 5. Angle C, AEC, we'll name it AEC. Plus angle AED equal 180. Definition of linear pair. And that leads to supplementary that they add to 180. Now we can set these equal. So I'm going to set line 4 and line 5 equal to each other because I can substitute the 180 for the 180. I can set those two equal. So my line 6 now, angle AED plus angle DEB, that's line 4, is equal to line 5, angle AEC plus angle AED. Now, why did I do that? How can I do that? Because of substitution. I substituted one equation into the other. They were both equal to 180. Substitution. And now I think we're almost done. Now look at my blue line 6. I have angle AED on the left of the equals and angle AED on the right of the equals. So if I subtract angle AED from both sides of this equal sign, this equation, what's left? We're left with angle AEC is equal to angle DEB. Subtraction property of equality. Subtraction. We did a subtraction of angle AED. So we have this in 7 steps. The truth is, we could probably tighten this up a little bit. And I guess we wouldn't have needed to put line 3 in there because we didn't really use AED and CEB being vertical. But we did use line 4 and line 2 with AEC and DEB being vertical. So up at line 2, we established that AEC and DEB are verticals. And at the very bottom, we finally established that they're equal and therefore they're congruent. We did it by showing 2 linear pairs using first this green linear pair, so the purple and the yellow that made up the green angle, and then we have a crossover with the blue linear pair, the purple and yellow that are making the blue, and we subtracted out from both sides that yellow angle AED. We subtracted AED from both sides, making the 2 purples equal. So that means that's always true. For every set of crossing lines, the vertical angles are equal to each other. They're equal in measure, which means they are congruent in their shape. Okay. Good Lord. It's already 12:45. Let's move on. Here's another thing that we'll need to do together. This kind of counts as a definition. So we've talked about angles. We've talked about congruence and congruent angles. That means the 2 angles are equal in measure and equal in shape. So that now we need to define transversal. A transversal is a line cutting through or intersecting through other lines. I know this is very general sounding, but there's our definition for transversal. So here's going to be 2 parallel lines. Line AB, below it, parallel to it, we'll have line CD. So these are parallel, they're never crossing. The transversal is going to be a 3rd line cutting through the 2 parallels. Here it is in red, going sideways. Let's label some of those intersection points. So the top intersection will be point E, and the bottom will be point F. Now, we just proved that vertical angles are congruent. To make this a little faster, since we're running low on time, I'm going to label our angles with some numbers, okay? So let's change our color. I'm going to change this to purple again. So I do want to practice naming our angles using all 3 points, but for this, let's go ahead and just number them. So in purple, here's angle 1, angle 2, the wide one, and angle 3 and angle 4. So I'm just naming it around. And then below, we've got more angles created. This is angle 5 angle 6, angle 7, and angle 8. Congruent angles. So first, let's just notice that when we have two parallel lines and a transversal cutting through them, we've created 8 different angles, and we've got a bunch of congruencies going on. For instance, angle 1 is across from what? Let me ask you guys, can you identify angle 1? And then what's the angle vertical to it or across from it? What's the angle vertical or across from angle 1? Go ahead and type it in the chat if you think you see it or if you want to try answer it, please. Nice. Anaya, Tatiana, thank you both. When we say across from, we mean like straight across the point, the intersection point, and it won't be across a line, it'll be across the point. So angle 1 and angle 3 are vertical, and we just established that that means they have an equal measure. Angle 2 is vertical to angle 4. So they're across from each other, and now that means they have an equal measure. Let's try the ones below. How about angle 5? Angle 5 is congruent to angle 7 in this picture. And angle 8 is congruent to angle 6. Nice, Tatiana. Thank you. Good. You're right on point. Angle 5 congruent to angle 7. Now, there's a couple more congruencies going on here. We can actually compare the top set of angles, the 1, 2, 3, 4 angles, to the bottom. Because the two green lines are parallel, we get corresponding angles. So corresponding angles are angles that are in the same position. The green lines are parallel. So angle 1 at the very top, what's in the same position below as angle 1 is? See how there's like a set of 4, 1, 2, 3, 4, and then at the bottom we have 5, 6, 7, 8. So which one of the 5, 6, 7, or 8 are in that same exact position, like the top left? Angle 5 is in the top left. Ooh, in the chat? Very good, Savannah. Exactly. So corresponding angles are angle 1 and angle 5. Those are in the same position. And because they're parallel, the green lines, it means that angle 1 and angle 5 are also congruent. So that means all of the corresponding angles we see are congruent. Angle 2 is congruent to angle 6. They're corresponding and they're congruent. Angle 3 and angle 7 are in the same position. And angle 4 and angle 8 are in the same position. So they're also congruent. They're corresponding and they're congruent. There's actually a proofs we can do to prove this, but for today I was just going to give it to you as a definition. Now check this out. Because we have the vertical congruencies, like angle 1 is congruent to angle 3, they're vertical, but then we said, okay, corresponding angles are congruent. That means that angle 5 and angle 3 above it, they're not vertical to each other. Look at angle 5 and angle 3. They're not vertical, right, at all. However, angle 1 is congruent to angle 3 because of vertical. Here's a mini proof. And angle 1 is congruent to angle 5 because they're corresponding. So therefore, we can substitute now 1 can switch out with 1, that 3 is congruent to 1, and 5 is congruent to 1. So that means angle 3 is congruent to angle 5 through substitution. We substituted the two congruencies above into each other like we can with two equations. And the same thing would work for many of these. Angle 1 is congruent to 3, but 3 corresponds to 7, doesn't it? So that means angle 1 is congruent to angle 7. I'll write that one out in orange quick. Angle 1 is congruent to angle 3 because of verticals. But 3 corresponds to 7, so we could state that 3 they're corresponding. And if we substitute 7 in for 3, because both of my congruencies I've written have 3's, right? So the 7 can switch out. Angle 1 is congruent to angle 7. Through substitution, that's how we did that. And therefore, angle 1 and angle 7 are congruent, even though they're not even touching. They're not even close. They're built off of different line intersections. So angle 1 is the same shape as angle 7, way down there. It's almost time to go. And per the usual, I didn't finish everything I wanted to do with you today. So my apologies on that. Since we're going away on spring break, I want you all to understand there's no class next week. You all got a week off from Josiah. However, when we come back, it's going to be Monday the 21st, and I will send out some information, emails and texts to those of you on my text remind with reminders about no class next week and coming back on the 21st. I wanted to just point out we can do proofs in different styles. So everything we've done so far, yesterday and today, were these ones on the left of our screen, 2-column proofs, where you write your statements, you write your reasons, and then you just list every thought process one at a time until you get to the what you want to prove at the bottom. You can also organize this in a different style using these other two ways. A flowchart proof, we start at the top with our given, and that leads to the next statement. This would be another line right here. So this would be like line 1, line 2, line 3, and then line 3 and line 2 are combining to make line 4. Then they have this info, line 5, that gives you line 6, and then they're ending with their statement at the very end, their proof at the end. And then here's another version, a paragraph proof. This is kind of like the one I looked up online. It wasn't written as a flow chart or a 2-column proof. It was just like how you say it. And there's nothing wrong with that. This is just writing out the thoughts one sentence at a time. So it is given that H is the midpoint in the diagram. So they're like saying given, and what is their statement? It's this business. So it's like a verbal description written out, basically. And that's cool too. I think in Edmentum, we're going to see all three types. Mostly, we do focus on the 2-column proofs. The information will always be like the same, however we choose to do the proof. Okay. I don't have time to do many of these. So, if you didn't even finish together as a group, I don't feel comfortable assigning you the homework. So here's what we're going to do. I'm going to let you guys go for today. Have a terrific day and weekend and week off next week. When we come back, we're going to jump right back into proofs and we're going to do that mastery test together and then just keep rolling through the unit. Savannah, thank you. You have a terrific break. Goodbye, everybody. Have a good break. We'll do more proofs when we